Good day, everyone. My name is Jim Swanke. I'm the Director of Risk Consulting at Willis Towers Watson, and I'm joined by my colleague, Ann Conway, who is the Managing Director of Casualty Actuarial Services. One of the hottest captive trends over the past 18 months is putting emerging risks like cyber risk and wage and hour risks into captives. In addition to providing coverage for these important new risks, these risks are generally not correlated with traditional captive risks such as general liability, auto liability, and workers' compensation, which provides a not so obvious benefit for captive owners. By adding these less correlated risks, a diversification effect takes place, reducing the volatility and variability in captive losses, plus reduces the necessary captive capital. This diversification effect in captives is similar to what investors learned long ago when they combine non-correlated assets in their investment portfolios. So the movement of one asset in the portfolio will be partially offset by the movement of a second asset, reducing the overall volatility of the investment portfolio. Ann and I first worked with the investment banks in New York City more than 10 years ago to better understand the diversification effect of placing non-correlated risks within a captive, and the actual diversification effect was substantial. However, the mathematics to measure the diversification was rigorous and long, often taking many hours to complete. Fortunately, Willis Towers Watson has developed a suite of software products to help our clients better understand the interaction of risks in their captives. And one of our software products is called Igloo, that measures the diversification effect in real time, plus assists our clients in conducting what-if scenarios, including changes to captive deductibles, limits, coverages, and reinsurance attachment points. My colleague Ann Conway will now walk through a series of slides that shows how understanding the interaction of risks leads to better captive decision-making and long-term planning in captives. Ann?
Thank you, Jim. Moving along to slide 1, this process of captive, what we call optimization, involves a number of steps. At a high level, we're looking to do a few things. The first is to measure the loss exposure. So for each of the risks that you're contemplating to put into the captive, we need to have a sense of what's the frequency of claims and what's the severity of claims and the distribution of those claims. That data is typically gotten from actuarial reports or from additional analytics. In some cases, it's supplemented with industry information, as there may not be a significant amount of loss history that was seen historically, particularly when you're looking at something like an emerging risk. Another important piece of the process is understanding the financial metrics of the captive, but more importantly, the risk appetite of the owner. For example, does the owner want to have a bad outcome 1 in 10 times, or a 90% threshold, 2% of the time, 98% threshold, or something different? We then need to quantify the impact of the risk diversification that Jim has described. But more importantly, you also want to create a process to systematically deploy these analytics. This is not a one-and-done thing. This is something that you would do over the lifetime of the captive each time you wanted to restructure the risk financing arrangement of the owner organization. I'm going to move on to a simplified slide which sort of highlights this. In this next slide, we lay out, as of December 6, 2016, a simplified balance sheet for a captive. So, for example, the purple box shows the held assets. In this case, they're $90 million. The held liabilities in the green box are $70 million. And the held capital is the difference between the two, or in this example, it's $20 million. As a way to test this captive, historically, the way you would look at capital to determine if there was enough capital or too much capital is you'd look at metrics. For example, a leverage ratio, looking at the premium to surplus. You may look at the reserves to surplus. You may look at a certain metric of the number, the largest occurrence, times 10, the old New York rule. But none of these actually capture the effect of diversification. So what we do in our modeling process is actually stress the assets and stress the liabilities. So stressed assets are less than the held assets, and stressed liabilities are greater than the held liabilities. Again, that makes sense. We run it through a series of modeling processes where in the stressing the assets, investment yields are different and lower than anticipated. Stressing the liabilities, results are worse than anticipated. So naturally, the stressed capital is less than the held capital. In this case, we're looking at held capital or at a 90% confidence level, and that comes out to be about $11 million at the 90% confidence level as compared to the held capital of $20 million. So if you were an owner whose risk capacity was you were comfortable at the 90% confidence level, in this situation, you'd have excess capital of $9 million, which you could either use to dividend or you could use to add additional coverage. One of the other things we look at is, well, what confidence level does the $20 million capital actually imply? In this case, it's a 98% confidence level. So if your risk tolerance for that you could only stand to have an adverse outcome 2 in every 100 years, then the captive would be adequately capitalized from that perspective. A key piece of actually doing this modeling process is understanding the correlation across coverages. What we're laying out here are dependencies across coverages. For example, if we're looking at the dependency for auto liability and auto physical damage, it's intuitive that you'd expect that those coverages would be correlated at a pretty significant level. In this case, we're looking at 75% of the time. If there's an adverse outcome on the auto liability, we're expecting there'll be an adverse outcome on the auto physical damage as well. You look to the other extreme and see something like wage and hour relative to auto liability. We would say in this case there's about a 10% chance that both coverages, wage and hour and auto liability, would actually have adverse results that followed a similar pattern in the same period. And each time we build a scenario, we'll put together a series of dependencies, which are constructed based on data from a client, based on industry data, and then based on some general intuition. Coming back to where I started, you would expect that auto coverages, whether they be a liability book or physical damage, certain events would drive the two together in a negative way or potentially a positive way. The last place where we use this is looking at how you'd put new coverages into a captive. I'm going to move on to the next slide, and where we look at the capital requirements that you would need if you were adding new coverages. In this example, we've looked at 4 different coverages, risk 1, risk 2, risk 3, risk 4, and looking on a standalone basis, so as if they were each in a silo. Risk 1, to add it to the captive, would require an additional $15 million, risk 2, $13 million, risk 3, $4 million, and risk 4, $5 million. So if you were looking at these in a siloed effect and just adding them up together, to put the 4 new coverages into your captive, you'd need something like $37 million of capital. If you look at the diversification impact, that's the yellow bar, and that's about $12 million. So looking at the 4 together gives you a capital requirement that's $12 million lower than looking at them in silos, or a capital requirement of about $25 million. At this point, just wanted to share some contact information with you. My name is Ann Conway. My phone is 617-638-3774. My colleague Jim Swanky is 952-842-6728. Thank you for your time.